So I have an example problem written out here for a parallel circuit, and I've set my battery voltage is 18 volts, resistor 1 is going to be 3 ohms, and I made resistor 2 6 ohms, and these two resistors are connected in parallel. You can use this exact same method for if we've got 3 resistors or 5 resistors. I just wanted to keep it pretty simple for our example problem, and I just stuck with 2 resistors. So let's go ahead and work through filling in the blanks. And there's actually a couple different orders you can do in order to fill in these blanks. I'm going to show you guys one method, and then just like with series circuits, remember there's always going to be one relationship you did not use to solve, and we can use that one to check our work at the end. So one of the first things that you should be noticing with parallel circuits is that the voltage is the same across the battery as it is across our resistors. So we can start off by saying the battery voltage is equal to the voltage across resistor 1, which is equal to the voltage across resistor 2. And those voltages are going to be, in this case, 18 volts. So I'm going to go ahead and fill in 18 volts for resistor 1 and resistor 2. And again, that is only because this is in parallel. That does not work in series. Okay, now you should notice here that I have 2 of the 3 values filled in for each of these rows. That means I can use Ohm's law in order to calculate the missing value. So Ohm's law is V equals IR. Okay, and then we want to solve for current here. Remember, you can always plug the numbers in and then solve, but let's go ahead and solve first. So, because sometimes it's helpful to do that once and then you can just kind of keep doing that. So I want to solve for current, so that means I want to get rid of R. Okay, so R goes away there, and I am left with I equals V over R. Okay, and so now we can do this for I1 and I2. So I1 equals V1 over R1. I'm just going to pull that from the chart. So V1 is 18 volts and R1 is 3 ohms. So we're going to take 18 volts over 3 ohms of resistance. 18 divided by 3 is 6. So our current across the first resistor is 6 amps. I'm going to fill that in up here. And then we can do the same thing for resistor 2. So I2 equals V2 over R2. And voltage across resistor 2 is also 18 volts. Again, in parallel, it's the exact same voltage across each resistor in the battery. And then the resistance across our second resistor is 6 ohms. 18 divided by 6 gets us 3. So we have 3 amps of current going across resistor 2. Okay, and now I look at my middle column here for current. I know all the values except the top one. So we can use our equation for current in parallel in order to solve this. Okay, and so if we remember, in parallel, your current that goes through the battery, or you can say total current, either way, is equal to the sum of the current going through each resistor. Remember, what happens is our total current splits when it gets to the branch in the circuit, and then some of it goes through resistor 1, the rest of it goes through resistor 2. So if the current going through resistor 1 is 6 amps, the current going through resistor 2 is 3 amps, 6 plus 3 is 9 amps. So our total current traveling through the battery is 9. Okay, and now the last square to fill in is the resistance. There are 2 ways to do this right now. I'm going to show you both ways because they're both important. Let's start with the easy method. So the easy method is to use Ohm's law for the entire circuit. So we know the battery voltage is 18, the current flowing through the entire circuit or through the battery is 9, and let's calculate the resistance. So once again, we're going to have Ohm's law, so V of the battery equals I of the battery times REQ, that stands for equivalent resistance. I want to solve for R, so that means I have to divide both sides by I. I's cancel. So our equivalent resistance for the whole circuit is the battery voltage divided by the current traveling through the battery. And we said our battery voltage was 18 volts. And then we just calculated that the current going through the whole circuit or through the battery is 9 amps. 18 divided by 9 is 2. And so we get 2 ohms for our equivalent resistance. Okay, and remember, one of the characteristics of parallel circuits is that we see a decrease in resistance. So as we add resistors to our circuit, the overall resistance decreases. That because we are giving more places for current to flow. Not all of the current has to go through every single resistor. As we add resistors, less and less current has to go through each resistor, so the overall resistance decreases. Okay, so now let's check our work, and we're also going to use this equivalent resistance equation to show that if we have a 6 ohm and 3 ohm resistor in parallel, our equivalent resistance is 2 ohms. So here's how we solve for equivalent resistance in parallel. Much, much different than in series and trickier mathematically. Okay, so we have the equation inverse equivalent resistance equals the inverse R1 plus the inverse of R2. So how we're going to fill this in looks like this. So 1 over Req equals 1 over 3 plus 1 over 6. Okay, and so now you could go ahead and just solve this in your head. Okay, but it requires adding fractions and finding a common denominators, which has been a while since you guys have done. So I'll show you guys 2 different ways on this one. So this guy is 1/3 plus 1/6. In order to add fractions, I need to have the bottom numbers be the same. So my least common denominator here is 6. So I want to figure out, how do I turn a 3 into a 6? I multiply by 2. Whatever I multiply the bottom number by, I have to multiply the top number by the same thing. So it's like I'm multiplying this fraction by 1. 2 over 2 is the same thing as 1. So I'd have 2 times 1 is 2. 2 times 3 is 6. So 1/3 is the same as 2/6. We're going to add 1/6 to that. Now, here's another reminder with fractions. When I add fractions, the denominator has to be the same in all the fractions, and it stays the same. We don't add them together to get 12. So the denominator stays 6. We do add the top part of the fraction. 2 plus 1 is 3. Okay, and so now what we have is this equation. 1 over Req equals 3 over 6. Okay, the equivalent resistance does not equal 3 over 6, rather the inverse does. So what we need to do here is just go ahead and flip both sides of our fraction, or both sides of our equation. So this turns into Req over 1 equals 6 over 3. Okay, so notice I flipped. I put the 6 on top and the 3 on the bottom. Okay, this Req over 1, that 1 doesn't really matter. And I can see, oh, 6 divided by 3, that's easy, that's 2. And so our answer here is 2 ohms, which is exactly what we got up here. Okay, let me show you one more method. And here I'm going to use the calculator for this, because that's how you're going to do most of these. Even if they're easy fractions, just use your calculator. That's fine, because sometimes you're going to have ones that you are just not going to be able to do by least common denominator this way, so we're not even going to bother with that. Okay, so we got 1/3 plus 1/6. So here's what you're going to do in your calculator. So we're going to type in 1 divided by 3 plus 1 divided by 6, and we get 0.5. 0.5 is not our final answer. Common mistake. We're like, oh, that looks great. 0.5 is 1 over Req. In order to get equivalent resistance, remember, I have to flip it. So if I flip this guy, I get Req over 1. Okay, and if I flip 0.5, I can think of this as 0.5 over 1. I'm going to get 1 over 0.5. Okay, so in your calculator, you have a couple of options. If you have a graphing or scientific calculator, you might have a button that looks like this, x to the negative first power. That is your inverse key. That will take the inverse of your number and it flips it around. The other way to do this is the long way. Just take 1 divided by the answer that you got up here, and that will be your answer, okay? So 1 over 0.5 is equal to 2. Okay, so lots of different ways in order to get your answer here. I am going to guess that this is the method you guys are going to gravitate towards, where you're just using your calculator, and I am totally fine with that. You do not have to do this longhand with fractions. Just remember, when you add up these fractions in your calculator, your answer is not your final answer. You have to take the inverse of that. So it's kind of a two-step problem there. So when you're solving parallel circuit problems, sometimes you're going to need to calculate the equivalent resistance using that inverse equation. Okay, sometimes, like in the example up here, you can see I didn't even need to use that to solve for all of my answers. It just depends on your givens.